Hello everyone. Welcome back. Welcome back to the stream. Today is day 77. We are almost getting close to 100 days. And I can tell you, I've learned a lot of things. I can tell you I've learned a lot of things. So, where did I drop my pen? Okay. Sorry about that. So today we are going to cover quite a few things. Like I said, it's a revision period, so I'm going through every questions I've solved previously, and I'm trying to, improve my understanding of those questions, and also reinforce um, the understanding of those questions as well, so I can recognize um, patterns that are similar to that same question, and also be able to solve um, questions like that when I meet them in an interview. So, here's what I'll do. A quick recap. So, yesterday I went over a couple of questions. So, I've been keeping track of every question I've been revising so far. And we are going to revise quite a number of them today. I think we'll revise at least three questions, and just so yesterday I was working on sliding window, and I also started writing down notes about each question, and the way I understand them, especially when it comes to the algorithm themselves, and also the different, I will not say tricks per se, but like the different ways to solve the questions. So I wrote a note on sliding window, and I'm not done yet. But regardless of where I got to, I'll be sharing these notes on GitHub, so you guys can have access to this and read. And if you have any opinions, you can also share them as well. So here is the sliding window algorithm that I've been revising. I solved a lot of questions in this algorithm. So far, I've solved about I think 1, 2, 3, 4, 5, 6, 7, 8. More than, I think, 15 questions so far when it comes to the sliding window algorithm. So um we can still continue, right? So which ones have I revised so far? Oh, I didn't revise anyone, because when I'm revising, I always create a revision folder. So let's see what's going on here. So repetition is here. Contains duplicates. Okay. This is not a sliding window problem, so maybe I must have, you know okay, so a problem like this can be a sliding window problem because of the way it is, right? I mean, we can. Okay, yes. I think I need to move this back to a sliding window folder, right? I mean, length of the longest substring, that's a sliding window problem. This is question what? Question 242. Should be in sliding window, not in array. So I'll just create a directory called repetition. Now the repetition folder contains things that I've revised, so it helps me know if I've revised something or not. Repetition, repetition folder, and we'll have, so I'll just move this one here, 242. I'll move 242 to this folder, to repetition. Yeah. Now this is supposed. Hold on. What have I done? Valid anagram. This is not an anagram. Question. Longest. Oh, come on. I've made a lot of mistakes. Wait, I need to correct this because the you know I'll say length of the longest substring without repeating characters. What number of question is that? This is question number 3. So this is a sliding window problem. I think I've solved it before. Yeah, longest substring without repeating characters. I didn't even name it well here. So let me rename this. Refactor. This is lit code. Come on. Lit dash number 3 dash longest substring no repeats dot bar. Okay, this is good. So this is lit code number 3, and I'll put this one here. Refactor, rename. You know what? Cancel this first. Copy this. I'm just trying to properly arrange stuff here. So from this part here, we can copy. Yes. So this is repetition 1, meaning I've revised it for the first time only once, and I will do this for as long as for as many as 10 times. I can solve the same question 10 times, but the trick is to give a day or two margin between the day the question was solved and the revision time, so I can also reinforce that knowledge of the question. So let's see what we have here. So we've done this, and what are the questions I need to revise now? So longest substring without repeating character is done. This question I've not solved before, right? So I think it would be nice to solve. Just to think about it and see what we can do. But I'm not going to. I mean, since I'm doing revision, I'll just keep this on the side for now. And I've also solved this question as well. This is also a how do you call it? A sliding window problem, but in the linked list side, right? On the other side, we're solving with arrays, but let's see. This question is actually quite you know straightforward, but mm, 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 mm. Okay, so let's see. I was explaining this question yesterday, and it's also a sliding window related problem. Given an array integers nums and an integer k, return the number of contiguous subarrays where the product of all elements in the subarray is strictly less than k. So here's a note I made on sliding window, and I'll read that quickly so we can apply certain things in this case. I'll close this part. Hopefully, you can see my screen. Let me increase this. I think you can do Control Plus. Yeah. Okay. So the sliding window algorithm. So this is my own notes. A note to myself, and and something I want to share with you guys as well. So when to use a sliding window? If the question, okay, let me put this. So when the question asks to return or work with a subset of a larger iterable, which is either a subarray or a substring, then we can consider using a sliding window algorithm. Now, understanding the sliding window algorithm. The sliding window algorithm involves working with values within a known or an unknown range. Sorry, let me read that again. The sliding window algorithm involves working with values within a known or an unknown range. The window is actually the distance between 2 points. The point can be denoted by left and right. The point can start at the same position for an unknown size window, or on the other hand, they can start at separate indices to contain the exact amount of elements that the window has to be within. Oh, sorry, the exact amount of elements that has to be within the window. To verify the size of the window, we can do size is equal to right minus left plus 1. So let me show you what I mean by that. Here we have I'll just erase this. I can't erase. Okay. But I can do this, right? I can pick this side and delete the rest. Okay. So here we go. Okay. Right. So we are giving in this place here, right? You know what? Let's read the whole thing. I wish I could, push this to GitHub, but I'm not done yet. But basically, let me read this again. The sliding window algorithm involves working with values within a known or an unknown range. The window is actually the distance between 2 points. The points can be denoted by left and right, which is the variable names. You can call them L and R. In some cases, you will encounter a namings like that, but we are usually put left and right, so it is clear to understand what is there. Now, the point can start at the same position for an unknown size of window. On the other hand, they can start as separate indices or indexes. I think it's indexes. I can put indexes. They can start at separate indexes to contain the exact amount of elements that has to be within the window. To verify the size of the window, we can do size equal to right minus left plus 1. So here is so to use the sliding window algorithm, it has to be performed on an array or any type of variable, which is also a string. So far, I've used them on arrays, strings, and linked lists. So let's say we have an array like this. We have 1, 3, 6, 2, and 4, right? Now, the size of the window can be fixed or unknown. So when we have a fixed size of window, let's say we want 2 items from this array at a time, we can put our left and right pointer here. Now it means we have the window starting from this point all the way to this point, right? And then we can slide the window across by moving it across the items, right? So the left pointer and the right pointer will increase simultaneously. So left will move to this point, and right will move forward by 1 step, and the left pointer will also move forward, and so on until the right reaches the end of the array, and then we stop moving the pointers. On the other hand, right, if we don't know the size of the window, right, the left and right pointers have to start at the same position. So here's what I mean. So we'll have the left and right pointer here like this, and they will point to the same element at the same time. So they'll both be here, and then we'll begin to increase them across the window. I mean, we'll begin to increase the window across the array based on certain conditions. So the right pointer will move to this point. So let's increase the window. We can increase the window by simply dragging like this. So the left pointer will move here, and and so on, right? So let me move it like this. So we'll keep moving it like this until we reach the end of the array. And that's what the right pointer does. So the right once the right pointer moves, right, the window size increases, right? And the size of this window, right, determines how many items have to be in our sub array, right? So to determine that, we can simply do right minus left plus 1, right? So this will be L is at index 0, which is 0 plus, so 0, 1, 2, 3, 0 plus 3, right, plus 1 will give us how many items we have in our window, which is 4. If you count this, you'll see we have 4. So this is 1, 2, 3, and 4, right? So that's how we can determine how many items we have currently in our window and how to, you know, create a window, expand the window, and slide the window across the iterable data type, which is in this case the array. And also there is one more thing left. There are cases where we will need to shrink the window. Now for certain conditions, if the window if the items in the current windows in the current window do not satisfy the condition for increasing the window, then we'll have to shrink the window until the items are once compatible with the condition. So let's say we have this current window and we don't want um, any prime numbers in this window, right? So we can shrink the window from this point to this point. So we can shrink the window. So to shrink the window, we simply move the left pointer towards the right pointer until the conditions are met again. So I'll just move okay, we'll say any number that is not divisible by 2, right? So we'll shrink the window for that to happen. So when we get to this point, we'll move this all the way to this point and the window size becomes small again. Now you can see the size of the window varies, right? And which is why I said there are two types of conditions for us to use the sliding window algorithm, where the first condition will be when we know the size of the window, which means the window has a fixed size, or an unknown size of window, right? Which means it can be large as long as the conditions are satisfactory, or the size of the window can continue increasing as long as the items within that window satisfy the condition for that window to continue increasing. Otherwise, when the conditions are violated, we shrink the window by moving the left pointer to a higher index, right? So which is what we need to do. And let's say we have this question. Sorry, I was reviewing it in the wrong place. We have question. Okay, I'm coming. I'd explained this yesterday, I think. Did I not? Yes, I did. So maximum, not this one, not this one. Yes, so let's see sub array product less than k, right? Now when you read this problem, there are two things we'll be able to conclude from this problem before we start solving the problem. First of all, let's read the problem. So given an array of integers nums and an integer k, return the number of contiguous sub-arrays where the product of all elements in the sub-array is strictly less than k. Now, there are a few things for us to note here. First of all, we want to return the number of contiguous sub-arrays. So we hear sub arrays, well, what does that say? It means we are probably going to use a sliding window algorithm in this case. Now, where the product of all elements in the sub array is strictly less than k, right? So now we don't know um how many elements we'll be able to return at this point. So meaning our window will have an unknown size, right? Because we don't know, if they told us to return exactly 2, then we'll know our window will have a size of 2. But now we don't know how many items have to be in the sub array, right? So and also we are looking for the product of every element. So here's what we need to do. Now this is our input. Is this our input? Yes. I'll bring this here. So here's our inputs, right? We have 10, 15, 2, and 6. So which is what we have here. I'll delete this part. And we want to return the sum. We want to return every possible sub array, right? Where the product of its items is less than k. So the first thing we need to know is that the array has to be contiguous, right? Sorry, let's read this again. Return the number of contiguous sub array, right? Return the number of contiguous sub array. So when we hear contiguous, right, it means, you know, the integers or the items in the array have to be one after the other, right? We can't have, 10 and 2, right? 10 and 2 is not contiguous. This breaks the rule of contiguous. So we need to start when we have this 10 here. The next one we have to look at is 5, and then 2, and then 6. This is what contiguous really means, right? Hello, Comfort. So we then take so in this case we want to find the product of we want to find the number of contiguous sub array where the product of all elements in the sub array is strictly less than k. So the number of sub array, meaning we are finding sub arrays here where the products of the items in the sub array is strictly less than k. So the first thing to understand here is that even an array like this, right? This is an array, right? An array with one item in it is also an array. But when we look at a larger array and we want to find out every sub array from that array, one of the sub arrays we can have is this. As long as the item in the sub array is also part of the larger array, that item on its own is a sub array of the larger array. So the possible values that are less than k are every items in this array. I'll call this nums. In this nums array, as long as the item is less than k, right? So our first sub arrays will be 10, 5, 2, and 6, like this, right? We know all of these are less than k, so that's our first bet. Now the second thing we can do is to find the contiguous sub arrays. Don't mind you, this is also contiguous, but we want to find more than just one item in the sub array. So let's say when we start from this point, we can look at this, right? We can look to 10. So this is 50. So this will be 10 and 5. Then we can go just applying the contiguous rule, right? When we look at this point, we can see this is 3 items in the sub array currently. So this will be 10, 5, and 2. 10 times 5 is 50. 50 times 2 is 100. So we can't add this as our sub array because we want items, we want the product to be less than k. So we move on. So we exclude one of the items that existed before, and then we continue with the rest, right? So hold on. So we have 10 and wow. We have 10 and 5 here. So we can add 2 there. Then we can have from 5 to 2. 5 and 2 is valid. 5, 2 and 6, right? This is also valid. So 5, 2, 6, right? Because this is 10, this is 6, this is 60, or 12 times 5 60. So then the next one we can have is 2 and then 6, because this is also contiguous. So we can have 2 and 6, right? Now let's count how many sub arrays we've created so far. This will be 1, 2, 3, 4, 5, 6, 7, 8, 8 sub arrays. Okay, so the question will want us to return 8, which means we have 8 sub arrays as part of this num arrays, where the item in that array, where the items in each of these arrays have a product less than k. So how do we do this in terms of programming, right? I just wrote out the normal logic, or the normal way we can think about this. Well, first of all, we know the product of two items, right? Two integers will likely, because let's see. According to the input, right? According to the input here, all integer in the nums array will at least be positive. So we cannot have the product of two positive integers, two positive distinct integers, to be less than 1. So we can start with a basic product, which means we'll find the product of the first item. So we can say 10, right? And each time we find the product, we have to increment the count, as long as the condition for us to increment the count is actually valid. So here's what we need to do. We can start with a left and right pointer, right? So again, we are using the sliding window algorithm. Now we don't know the size of our window, right? Which means our window has let's see, our window has an unknown size, right? It says return the product of all elements, sorry, return the number of contiguous sub arrays, right? Contiguous sub arrays. Now, how many items has to be in those sub array? We don't know, right? So we can start with finding the product, the general product of the items in the array, and once the conditions are not met for us to continue increasing our window, then we shrink the window by moving the left pointer towards the right. So here's what we need to do. We can start with this. Let's say sorry, okay. If we had our left and right pointer, so for an unknown size window, we want to have the left and right pointer at the same position, right? So let me show you this. This is a known range, or a known size. An unknown size, when the range is not on, when the range is not known. In other words, the size of the sub array or substring is not known. The pointers will work differently. they will both start at the same indexes or indices, and the window will expand. mm, or the window will expand or shrink. Let me put this, or shrink when certain condition. Wait. So the window will expand when the condition is not violated, and the window will shrink. But let me say, but uh, okay, and will shrink if, not if, when the conditions are not met or violated. Violated. Okay. So the reason for that is that starting both pointer at the same position helps capture the smallest possible amount of items from our given iterable. In other words, a single unit of item in an array is a sub-array of the larger one. Okay, so that's what I was explaining. So this item here, right? For this particular problem, we'll start the left and right pointer at the same point, right? We'll start it as a single unit, so we'll have our left and right here. Now the reason why I want to have the left and right here is because this item here, this single item here, is also a subset of this num array, right? So we need to keep, our left and right pointer at this position and increase the window or expand the window by moving the right pointer across the array. Now, as we are increasing or expanding the right pointer, we also need to check for certain conditions. And once those conditions are violated, we'll shrink the window to, make sure that every items within that window actually conforms with the condition that was set in place. In this case, we want the product of every item within the window to be less than k. So in this case here, 10 is actually less than k. So meaning 10 actually passes the test, or 10 meets the condition for us to add it as a valid subarray. So we'll put 10 here, and then we increase the window, right? We increase the window. Now we have 10 and 5, right? 10 and 5 will increment, and each time we do this, right, we can simply just add this. So this is 10 and 5, and when we move this to this point, right, we can see we have 10 5 and 10 5 and 2, right? So 10 5 and 2, this is this is 3 items, which is exactly equal to k, which is not something we want. So we have to shrink the window by moving the left pointer until the items within this window satisfy the condition again. So meaning, after shrinking the window, we still need to check if the current items in the window are the product of those items is actually less than k, right, which is 100. And in this case, this is 5 times 2, which is 10. 10 is less than 100. So this is good. Then we can continue incrementing our window or expanding the window by moving the right pointer to the right. Okay, so that's basically what we need to do. And in this case, there's something special about this question, which I actually did not do for the very first time. Now, what I just explained is exactly what I wrote in my code, but there was a gotcha, or there was, something missing. Now, I said each item in the array, right, in this place, right, is a sub array as long as it is less than k. So if we were moving the left and right pointers across the array, how do we then count the unique items, right? Or the single items in the array. Like I said here, I said um, the reason for starting for this is that, which is starting the left and right pointer at the same position at the beginning, is that both pointers um, starting both pointers at the same position helps capture the smallest possible amount of the items from our given iterable. In other words, a single unit of item in an array is a sub-array of the larger one. So, this is what I meant by that, and we'll put that into action. Now, here is what we will need to do. I'll close that up and let me see. So we'll put the left and right pointer. Now, at what point do we count each one of these items as the as a valid subarray? Let me just call it that, right? Well, so this we want to be able to have 5 and so on. Well, in the course of iterating through every item in the array, we can actually increment the count for the we can actually increment the count for the number of contiguous subarray where the product of all elements is the subarray, right? In the subarray is strictly less than k. So we can actually increment the count for that for every iteration, right? And then now what we need to do then is to find the product of the items, right? And then remove the ones, or by shrinking the window, we are removing the ones that are not supposed to be there. And then we can still count, how many items we have in the contiguous subarray so far. So for in this case, right? In this case, the left and right pointer will point to this, and we'll find the product of the current item within this window. So the product will be then 10, right? Now, when we increase the right pointer or increase our window, we'll move this to here. We have 50 now, right? So in this case, 50 is also good. We can add 50 to 50 to the list. So we can do something like this. We can say this is 10. We can add 50 to it, right? And this will be equal to 500. Don't worry, this is not what we want to return. And also, now the reason why we do this is because 10 times 5 is actually okay, so which means we can multiply this. Now we have to increase again. So when we increment this right pointer, now remember, in every iteration, right? In every iteration, we are incrementing the count. How many items or how many sub arrays have we had so far? Now, when we move to this point again, right? Now the condition is no longer true, right? For us to, add it to our total product. So we shrink the window. Now, when we shrink the window, right? Let me show you something that happens. I will erase this part here. After moving our window, right? After moving the right pointer to 2, right? We'll have 50 times, hold on, not 50. We are doing this, sorry, not 50, not 50. So we have 10 times 5, right? Which is equal to 50. And then we'll have 50 times 2, which is equal to 100, right? Now, how do we make sure that we keep this product, I'll call this P, and still be able to make sure that the current product we have is strictly less or equal to K? Well, that is fairly simple by just simply removing whichever is the largest number that is causing, or not necessarily the largest, but the numbers that we visited previously, until the items in the current window are again have a product that is less or equal to K. So when we move the right pointer to this point, right, when we move it from here to here, the condition here, the product here is 100, which is equal to K, and it's something we don't want. So we would remove the first item in the current sub array, or sub in the window, right? The first item in the window, just to make sure that we have numbers that are compatible for the current condition. In other words, we have the product of items that are strictly less or equal to k, not equal, so strictly less to k. So we have 5, 10 from the equation, right? 10 becomes, to remove 10, we simply divide it by 10. So this is 5 times 5 times 2, which is equal to 10, right? And then we add the next number to the window. We increment the window again. So we increment the window to this point. And then we have so our window our window would have shrunk, right? So we'll have 526. So we'll do 5 times 2 times 6. This is going to be equal to 60. Excuse me. So this is equal to 60, which means come on, something entered my eyes. So we keep the product and we remove items that do not satisfy that increment the product the past k, right? This variable that we've been given. So we need to make sure that every item we add to our product, right, is actually within it actually makes the product of every item in the sub array, in the current sub array, less than k. So where we in this case where we have 100, it means we have to remove the first item, which is 10. If we still have 100 and something, we'll remove the next item until the left pointer shifts towards this point here, right? Until it shifts towards this point. So yeah. So let's write out the code for this. As you can see, we already have the code here, but I will explain this quickly. So we have this edge case here. I'm not sure why it is there, but anyways, the reason why so the reason why we are returning 0 in this case is that there's no way the product of two integers, right? Two integers in um there's no way the product of two integers has to be less or less than 1, which means negative number, right? Positive integers I'm talking about. I mean, obviously, if you do negative number times a positive number, you'll get a negative number. But in this case, the constraint is saying here, the constraint is saying that we have numbers that are less or equal to 1. So, sorry, the numbers that are superior or equal to 1, not less or equal to 1, superior or equal to 1. So here is what we need to do. We can then take what do you call this? We'll first of all calculate the product. The product will be 1. We set the product to 1 for now. A multiplication of a number by 1 is still the number, so there's no big deal here. Now we have the left pointer and the right pointer. Like I said, the left and right pointer are boundaries for our window. So they shift based on certain conditions, right? So if the left pointer is at a position where the conditions the items in the window respects or do not violate the condition, the left pointer stays where it is. Unless there is a violation, then the the left pointer moves past that point, right? So here's what we need to do. Okay, so they brought back lights. And yeah, like I said, so again, the distance to calculate the distance between two integers, right? I mean, the distance between the window is simply the right minus left plus 1. Sorry, I have to go and wash my face, my eyes. I'll be right back. So let's come here. I can see there are some comments in the chat. You guys are welcome. Um, hello Rajat. Hello Big Bad Boy. You're welcome. You're welcome. All right, so let's continue. So we can write the code for this solution. What number of question is this? This is subarray product less than k. So subarray product less than k. Leads code 713. So it will be in the revision folder. New leads 713, right? 713 leads dash 713 sub array product so this will be repetition 1. Come on. Du, du, du. Du, da, da. Hello Shamila, thank you very much. Thank you. Yes, 10 million very soon. Subscribe. Yeah. Okay. So to see something there. uh, pa, 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 pa. So we have question. So it has to come into the repetition folder. Refactor. Yes, so we are repeating this question. Now I'm going to walk you through step by step. Um, so let's see. Step by step, step by step. Du, 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 dun, dun. Let's go, let's go, let's go. Let's go, let's see. Repetition, question. We need this. I'll copy those. Um, we'll just put them here. This will be our inputs for testing. Come on, you're not supposed to be here. You know what? Let me just put them here. Tired of this. So we only need num and k. This, let's import their class names. Okay, so we are done. So the first thing we need to do is we don't even need to check any edge case there because the constraints are good enough for us. So I mean, if k is equal to 1, then we can return 0, right? So let's say we have we need a left pointer, so we have the left pointer equal to 0. Then I'll just create a dummy product, right? Now this dummy product is for us to be able to multiply the next item in the array with this one. And we know when we multiply an item with 1, we still get the same item, so it doesn't really make any difference here. Now here's what we need to do. We can iterate. So we want to return the number of sub array products less than. So I'll say num of sub array. I can just call the num of sub array. Sorry. And then we'll set it to, you know what, let's call it count. Count, and we'll set count to 0, right? We set count to 0, then we iterate through the array to add the current count to the to count the current item and also increment the product by multiplying it with the first item in the array. So we can just say for nums, right? For num in nums, we can simply use it directly like this. We don't even need the index at this point. We don't need the index. We simply need the item in the array, which is this number here. So we have 10, 15, and so on. So we'll calculate the current product. So the current product will simply be prod times equal num, right? Good. So prod times equal num. Hey, I put plus. It's times multiplication. Okay, now if the current product, right? So here's a little thing to be careful of. So we want to shrink the window. This here will increment the window, and this here will shrink the window. In fact, we will need the. Okay, we don't need it. So I mean, this is our left pointer. For every iteration, right? I could have used, let's use range. So I can say in range, in range length of nums, right? So this will iterate all the way to the end of the array, and we can use this as r, which is our right pointer. So we can just say right. Let me just use the right and left pointer. So this will be left, sorry, this will be right again. It will be num at right, nums at right. And then if the current product we have is superior or equal to k, then we'll shift the right pointer, right? We'll shrink the right pointer. So so if the current product, if product is superior or equal to k, right? If the current product is superior or equal to k, k is our current item, right? Which is 100. So if the current product is superior or equal to k, then we want to do something. So we can then we'll shift the current pointer, right? We'll use a while loop. We'll say while, come on. Wait, first of all, we want to be able to eliminate, right? We want to remove the item and then shrink the window. Remove, shrink, remove, shrink. So we'll first of all do the product here divided and equal to the nums at the left pointer, and then we shrink the left pointers. So we'll say okay, now we don't do it this way. We have to do it for every time we shrink the left pointer. So while what am I doing? Let's see. There's no need for us to check here, right? So if the while this is happening, sorry, while the current product, right? While product is okay. While the product is still equal to, hold on, I'm mistaken. Let me see. What did I do here? I'm so sleepy. I don't know why. These days when I'm recording, I just get really tired. Product first on T. Yes, So what if the product is superior or equal to k, then we do this. Because I'm not sure why I should be using this here. So instead of this, I'll just say while this, we want to remove that item from the product, right? So product division equal to nums at left, right? And then we increment the left pointer forward. So we'll say left plus equal 1 like this. And so we are removing when we find when the current product we have here is superior to k, we'll remove it by simply dividing and reassigning that division back to the product. So this will divide. So for instance, in the case where we have 3 items in the array already, this will do left will be at 0, right? So at this position here, so we'll remove left 10 from the current product. The current product would have been 100, so we'll divide 100 by 10. which is going to be equal to 10, and we'll reassign that value back to the product before shifting the left pointer forward, right? And then we'll do this again. So for every iteration, we have to increment the count, right? So count will simply be the distance, like I said here, the distance between the left and the right pointer, right? I wrote a note about it here. So we'll have the distance between the left and the right pointer. Where is it? Yeah, so the size of the window will be the right minus left plus 1, right? So that's what we are going to do. So the size of the window will be the distance between the left and right pointer. Now the left and right pointer will point to the inner or the sub array, right? So we are taking a particular sub array, which means we have to increment this instead. We have to increment the count as well. So we can say count plus equal right minus left plus 1. So this is everything we need to do. Then we return the we return the count at the end of the day. So here's what we need to do. I'll create an instance and test this out. An instance of the solution class. So solution is equal to solution like this, and let's print the solution. Solution subarray, I will pass in nums here and then k as well. So now we have 8, which is good. But here is something we also need to note, right? The time complexity of this solution here is O of n squared, right? Why is it O of n squared? So we are iterating for every amount, for every item in the nums array. And also there is another iteration here happening. There is a loop here, which means we are shifting the left pointer for every amount, for every item that does not satisfy the condition for multiplication, right, or product. So let's say in this case it will only happen once, because we will already detect that after after getting the current product, right? So let's say in this case we multiply 10 by 5 and then by 2. This is 100, right? I'm not sure. And in this case we'll just run this loop. This loop will only run once, right? It will not run more than once. It will only run once for us to remove the current the previous item, something we've seen before, until the conditions are again satisfactory for us to continue the loop. So in this case, I'll say the time complexity for this solution, this will run for O of n time for sure, but I don't know, we should call this m, right? This is m time complexity, so O of m times O of n. Yes. Okay, let's see. There are no questions in the chat. Okay, that's fine. Hello, Code Lifey. This, yes, I am. I'm getting yeah, but anyways, I think I'm a bit better now. Let me shake my head to remove the sleep from my face. Okay. So in this case we are shrinking the window, so we don't have a fixed size of window. And the same thing would have happened. There was a question, similar question, maximum sub array sum, right? maximum subarray sum, max subarray sum. Yeah, so you see, in the only difference here is that we are looking for the maximum, and we are also doing an addition um instead of a product, right? Multiplication, we are doing addition here. You can see we are removing the previous item, and then we are inserting the next one. mm, this is good, but anyways, I'm not going to solve this now. Let's move to another question, a much more interesting question. I saw the DNA sequence question today, and I would like to try it once again. So let's copy this part, and I'll create a. Let me close this. Let's create a new file called DNA. So sorry, this is the what's the number of the question? DNA sequence. I didn't even write the number of the question. That's really bad. Let's see. Repeated, I think repeated DNA sequence. Repeated DNA sequence, yes. So I'll do repeated DNA sequence, and okay, thank God there is no code here, so I will try my best to, you know. What was the last time I solved this question? Let me see. Submission. It was in May, so more than a month now. Uh, okay. Let's see if I can still solve this question. Repeated DNA sequence. Lead code 187. I'll call this leads dash 187 dash repeated DNA sequence. Repeated DNA sequence. Let's read the question and see. So the question goes, the DNA sequence is composed of a series of nucleotide abbreviated as A, C, G, and T. For example, here is a sequence, right? A, C, G, A, T, blah, blah, blah. Okay. So, when studying DNA, it is useful to identify repeated sequences within DNA. Within the DNA, sorry. When studying DNA, it is useful to identify repeated sequences within the DNA. Given a string S that represents a DNA sequence, return all 10 characters long sequences, which is also a substring, that occur more than once in a DNA molecule. You may return the answer in any order. So, here's what we have. We have an input like this, and we want to return all 10 letters long DNA sequences that occur more than once. So here's the nice thing about this question. Again, we are going to use the sliding window algorithm, but in this case, the sliding window has the window has a fixed width, right? We want to return all the string. We want to return the DNA sequence, right, which is 10 letters long, and also occurs more than once. So meaning we have to see every 10 letters long DNA sequence that repeats itself within the given sequence here. So I'll copy this string, and let's see if I can explain this. So paste and increase. You know what? I'll write this myself, because I'm not sure the space will be enough for me to. Okay, I think you can see this, right? I can see this on my screen, which is good. I hope you can see this as well. Anyways, so here's what we need to do. Here's what the question is asking us. We want to return all 10 letters long sequence that repeated at least once, right? Um so let's see. Where's the question? Longest repeated DNA sequence. Okay, so now we are given this long string, which is the DNA molecule, and we want to find out that repeated, right? So first of all, we know that the sequence, our current sequence has to be of 10 letters long. So we can choose any random 10 letters long sequence here. So we can start from this point. So this is one, two. Hold on. We can select this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here's our first sequence that we are looking at. So from here to here. Now we want to make sure that we still find this particular set of string, which is A, A. How many A's here? We have 5 A's. So you know what? I'll write it like this. We want 5 A's, right? And 5 C's. So if this repeats in the string, then we've seen a duplicate, right? So meaning 5 A's or 5 C's has happened, at least more than once. So the next sequence we can have can be from here to here. So let me write this. We can have from this point all the way to the next one here. So we can have 4A, 5C's, and 1A, right? And we can do this for every character in this string. So we are choosing 10 at a time, right? So the next one will be here to here, always 10 at a time. So we have so from this point to this point, so this is 3A, 5C's, and 2A, right? If you sum every A here and C's, you will see we have exactly 10. So this is 3, this is 5, that is 8. 8 plus 2 is 10. So I'm not choosing more than 10. So we'll do the same thing again. We'll move from here all the way to this point, right? We'll move till we get to this point here. So this will be 2A's, 5C's, and 3A's, right? 3A's to this point. So 2A, 5C's, and 3A. Okay, so we'll do the same thing again. I'm going to do it for every one of them so that we have everything written out. So again, we have 1A, right? You know what? Let me write the sequences in a different color so that it is actually easier for us to 5A, 5C. So I'll remove this part. Hold on. So 5A and 5C. Then we have 4A, 4A, 5C, and 1A. 4A, 5C, and 1A. Yeah. Then we'll write the next one, which is 3A, 5C, and then 2A. Now these are the sequences, right? So we can also do it this way. So let's see, 3A, 5C, and 2A. Okay, 2A, 5C, and 3A. So we have 2A, 5C, and 3A. Hold on, which one did I just delete? Okay. So the fourth one, right? 2A, 5C, and 3A. Um, when biology students meet, this kind of. Yeah. Oh my god. This question is hilarious. Anyways, let's continue. So, let's go on with the next sequence. You see, I'll later compare which ones have repeated, right? We want the sequence to be exactly the same. If we have a certain amount of A's on one side, it should also be the same amount of C's we have on the other hand. So here we can have from here all the way to here, right? So this is 1, 2, 3, 4, 5, and then we also have 1, 2, 3, 4, 5 A's as well. Now you can see something interesting is happening. So we have 5 C's and then 5 A here. Okay, so let's move on. So here you see it will diminish every time, but you know what? I still want to be strong headed and do everything. I'll write out every sequence. So let's see, we have five. Um, so in this case, we'll have one less C, which is 4C and 6A, right? We'll do this here. 4C and 6A. So from here all the way to here. Hold on. 4C. Is this 6A? We can not have 6A. Is sorry, this is my fault. We have 4C, 5A, and then 1C. Sorry about that. That was my mistake. So we'll do the same thing here. So this will be, I'll just draw a line here so that we can continue with the rest. This will be 4C, or 3C, sorry, 3C, 5A, and then 2C. Okay. Dun, 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 dun. From here to here. So this is 3C. So we'll write it again. Write 3C. Is this 3? 2C's. 2C, 5A's, and 3C's. Right? So we can add 3C's from here to here. That's 3. And the 2 are on the other side. So again, we are done with the C's here, right? I mean, we can take from here. We can take this one. Let me use a different color so we can go from here all the way to this point here, right? We have to choose 10 at a time because that is the size of our window, right? The window must not we are sliding the window across, right? Which is why you can see we are choosing 10 items at a time. So the window has a fixed width, right? So this is going to be here we have 1C, 5A, and then 4C's. So the next sequence we have here will be, I'll just draw it at the top. So from here all the way to this point, right? Is that it? 1, 2, 3, 4, 5. Okay, yes. So we have 5 A's, 5A, and then 5C. So let's move on again. We'll slide the window all the way to this point. Here we have 4 A's and 4 4A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 4A and 6C's. Okay, then from here to here, we'll have uh, 3A's, 3A's, 5C's, and then 1A, 1A, like this, right? We have 3A's, 1, 2, 3, 4, 5, 6. Oh, sorry, 6A, 6C's, and 1A. This thing is long. Oh my god. Do I need to write all of this? Well, I think you get the idea. Uh, oh, okay. You know what? Let me just finish it. I'm almost done. I'm almost done. Perseverance and go. We'll get to this point here, right? So we'll have 2A's, 2A, 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 6C, and then how many on this side? 1, 2. So 2A as well. So I'll do this here. Oh, I'm running out of space. From here to here. So we'll do the same thing. We have 1A, right? 1A, 6C's, and 3A. 3A. We'll go again from here all the way to this point. This will be 1, 2, 6C's, and then 4A. So we have 6C, 4A. Then we'll go again. I don't think I would need to include this part because I mean this will not be. Would it be? Nah, because I doubt this will be part of the duplicate. So I'll stop here. We'll have C again. So this is C. C starts from here. So 1, 2, 3, 4, 5. So we'll have 5C and then 5A. Okay, so from everything I've written so far, let's see which ones have repeated. So we have 5A and then 5C. Do we have 5A and 5C anywhere here? Yes, so we have 5A and 5C here. 5A and 5C have repeated. 4A, 5C, and 1A. 4A, 5C, 1A. 4A, 5C, and 1A. You really have 3A, 6C, and 1A here. So we have 3A. Sorry, we don't have this. 3A, 5C, and 2A. 3A, 5C, and 2A. Nope. 2A, 5C, and 3A. 2A, 5C, and 3A. 2A, 5C, and 3A. Nope. 5C, 5A. 5C, and then 5A. We have 5C here, and then 5C and 5A is also here. 5C, 5A, and 1C. 5C, 5A. 4C, sorry, 4C, 4C. Any 4Cs here? No 4Cs. 3A, 3C, 5A, and 2C. 3C, 5A, and 2C. I'm actually visualizing the entire thing here so that we can see what happens under the hood. Let's see. We don't have any 3C's left, do we? No 3C. 2C's, 2C's. We don't have 2C's. 1C, 5A, and 4C. 1C, 5A, and 4C. Nope. Which one again? Do we have this? 3A, 5C. We have 4A and 6C. You see, we have 6C before 4A, so these are not compatible at all. So although they have the same composition, but they are not structurally the same. So uh, yes, I'm running out of time. Yeah, I'll take you. Anyways, so here is this, and we let's just let's just stop here, right? I don't think there is any more duplicate. So far we found 5A, sorry, 5A, 5C, and then 5C and 5A as our duplicate. So this is what occurred twice in this DNA sequence here. So let's see the answer here. So we have AAA here, which is good. This is 5A's, right? And then we have CCC here, which is also 5C's. So 5A, 5C, 5A, 5C. Now, so that's all we need to do to solve this question, and we'll return the ones to the ones that repeated, right? So here's what I'll do. I'll write out so to solve this in terms of code, right? Let's scroll this up. I can use a set, right? Because set will help me keep unique values. So when I use a set, I can keep track of the items I've seen before, right? And if something existed in a particular set that I had before, then I can add it to another set. So let's say I get my first set will be this. So I'll have two sets. I'll call this set 1. I remember very well how I solved this. So I have set 1, which is the set of every unique items we have in this set. And then another set 2, will help me keep track of the duplicates. So for every 10 items I select in this range, if those 10 items already appear in this set, I can then add them to this set here. And at the end of the day, I'll just return a list form of this second set here, which is set 2. So that's how we can solve this question. Ouch. So let me sitting down for long. Okay, so let's go ahead and code this out. Let me bring up these parts. Where is my code editor? Okay, so we need the boilerplate code for these. Let's copy this part. Want to find the DNA sequence. Biologist. So ouch. I always just cracked. Okay, so let's do this. I'll put this here. We need this part. Okay, like I said, I'll use two sets. I'll say set. I'll call this set of unique sequence. You know what? Let's call this set of unique sequence. Yeah. So this will be my first set, and here I'll just say the second set will be repeated sequence. Set of repeated sequence, which will be the set of the repeated sequence here. Set, Right. Now we can begin to iterate through the our DNA molecule to get every possible set 10 characters long sequence and then compare them, right? So we'll say for, so I'll do this for I in range, the length of uh, our s is the sequence here. Now there's a problem, right? As you can see here, we we kept taking 10 items at a time, right? So meaning we should still be able to take the 10 more sequences, right? 10 more characters for our last sequence in the last iteration. Here's what I mean. If we get to this point, right? Let's say if we get to this point, let's say here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we get to this point, right, we should still be able to, select 10 more items in the sequence, meaning our iteration has to stop here, right? Our iteration has to stop here. So if we had, how many items are in this sequence now? I don't know, but like this is a lot. This is 10, 11, 12. Anyways, we want the length of this, right, minus 9, because we want to select 10 more items from here, right? So, and let's bring this. I see there's a question. So, TT said, how to project is this run to Python? Are you trying to ask how you would run this code in VS Code? I'm not. I don't think I understand your question. But anyways, please kindly rephrase your question so that I can understand and reply you. All right. So um, all we need to do is to iterate 9 less item than the original length of the array. We already know if we iterate the entire length of the array, it will iterate up to the length of the array minus 1, which is what this range does. So this range will do this, will iterate all the way to 9 minus 1, but in reality it's doing 9 minus 10. So it's doing the length minus 10, sorry. I really want to write the length of this thing out and see how it looks. So I'll copy this and put it in my playground. Wait, I hope I'm not writing the playground. Oh, come on. I'm in the playground. Playground. I needed to put it here. Repeated DNA sequence. So here. So I wanted to check something here, which is this. Let's see how long this string is. It's simple. We just do print length of this. Let's remove this here and run this. So now this is 32, right? Now do 32 minus 9. This will be 23, right? So we iterate up to the 22nd item, right? So 32nd item, and the remaining 10 when you add it back to 22, you get 32, right? Yes, 32. So we want 32. We want to iterate up to the 22nd item, right? And then, the remaining 10 will still be able to get those ones as well. So here's what we need to do. So after we iterate through this place, so we'll get the current sequence. I'll say current sequence. The current sequence will be, I like using kind of snake case. So current sequence is going to be equal to the current sequence is going to be equal to this. So we'll select, how do we select a range of items in a string? So we'll simply do this. We'll select from here, right, all the way to here. So we want to select 10 from this, right? I'll copy this part. Let me remove this. And then I can do this here. Oh God. I'll say S is equal to this. And then I can just say S at 1 from 0 all the way to, if I do from 0 to 10, right, this would select a range of uh, characters from this string, but it will not include the 10th item. So we always need to add 11, right, one more than what we want, so that we actually get everything we wanted. So this will select 10 characters for us. So let's run this. You can see this is 11, but let's do this. Oh sorry, we want all the way to 10, right, because this starts from 0. So yes, so let's see. I don't know what's this. Maybe I'm mistaken. I'm confusing myself. We want 10 items, right? So we need to select. This will not include the 10th item in the string. This will not include the 10th item in the string, because let's see, one. This is 5 and this is 5. So the last item is C here. So let's, okay, I'm printing the length out, which is not what I want. I want 10 items here. So from 0 all the way to 10, you can see, yes, we have 3 A's, 5, and for the C's we have 1, 2, 3, 4, 5. Yes, so this is 10, right? Let's see what we have to do. I've just tried to be careful here, because when R becomes, or when our I becomes 1, right, we don't want to do the 10 next items, right? Because this time around it will no longer be 10, it will select 9 items here. So you can see we have a, what is happening? Hold on. Wait, we have 3 here, 5, right? This is 10. Okay, plus 1. Oh, because in our first iteration, I will be 0, right? I will be 0, so I here will be 0. So we want to do S, right, at I to want to go all the way to, oh wait, you know what, there's a trick. Something is confusing here. We start from this point, which is 0, all the way, and we want 10 items. If we did this way, this will not work, because by the time we get to this point where I is maybe 23, I think, we can't do something like this. I don't think so. Right? This is not possible. So what do we do then? Can we do like I from I and then 10 more for I, like this? I plus 10. The 10 next item after I, right? Let's see. So if we do, let's say I is 23, 23 plus 10. 23 plus 10 here. Yeah, so this will give us 1. This is 3, 3, 5. Okay, so we know the entire length is 10, right? Sorry, 32. So if we do 32 uh minus 10, we'll have 22. So let's do 22 here. So is this up to 10? This is 6 4a. Yeah, I think this works. So we can go with this one instead. And then just do this. So say we can add to the unique set. So set of unique sequence dot add. We can add the current sequence to it, and then we just check if if the current sequence is in the set of unique sequence, right? Then we can just add it to the set of repeated sequence. Sorry, set unique sequence. Then set of repeated sequence dot add the current sequence. Okay, so we can then return a list of the sequence set of unique sequence like this, right? I think that's all we need to do. So let's test this out and see. So I will say solution. I usually say my solution. My solution is going to be equal to the solution class. So print my solution dot find repeated sequence of S. So let's see what we get. Ha! What have I done? I just printed everything again. Wait. Interesting. What did I just do? So if the current sequence is in the set of this blah blah blah, then we want to add it. Oh, set of repeated sequence. Sorry, it's not that one. This is the one I want to print. Come on, stop tricking me. Okay, so let's see what we get here. Again, set of repeated. How is this repeated sequence? This is not repeated because wait. Yeah, so if we are adding the current sequence to the unique sequence. Anyway, this one will filter out the. So if the current sequence is in the set of unique sequence. Oh. This is okay. I see. Maybe the error is just from here. After adding this, right? I'm still okay. This one will repeat it. Okay, I get it. So let's see if the current sequence is not in the Nah, this is wrong. Maybe I'm doing what the hell? What am I doing wrong? Hold on. Dun, 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 dun. You see, this is why you have to always repeat the questions you solved before. Honestly, I don't know what have I done wrong. Set of repeated sequence. Yeah, so I'm adding this will if the current sequence is in the set of unique sequence. You know what? Let's just take a look at what I did before. Oh, repeated DNA sequence. So here's what is. Ah, just. Mm. You see, I kept adding it here, which means so. This is all I needed to do. Else, add it to it. So if the current sequence is in the repeated DNA sequence, is in the unique set, right? We add it to this. Otherwise, we just add conditional. Anyways, here's your answer. Um, just a minor mistake, but yeah, we learn from it, right? So, anyways, I'll just add this git commit. I want to learn a new data structure. I think I would like to learn about trees, binary trees, and so on. So git commit dash m. This will be repeated. So this is revision date dash 187 lit dash I also solved the other question, right? Yeah, product less than k. So sorry, 713. Yep, it's push origin. Okay, I think that's all for today. Time's up. I will need to continue tomorrow. I feel like, oh my god, repetition is so underrated, and I feel so bad that I'm just realizing that now. Anyways, I'll see you guys tomorrow. Stay coding, right? Any questions? Any questions? Do we have any questions in the chat? I'll wait for 5 minutes to see if there are any questions. If not, I'll end the stream. 5 minutes is too much. Let's say 4 minutes or 4.5. 4 minutes. Is Code Lifey still here? Code Lifey, what's your name? I want to know your name. Uh, I'm sure Code Lifey is not your name, but anyways, your internet name is Code Lifey. Uh, do, 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 do. All right. So there are no questions. I think. Uh. Rosemary, I've answered you before, but anyways, 3 years, 3 years. Yeah. All right, guys. I think I've I've reached the end of this stream today, and we shall continue tomorrow. Cheers.